Hello, everyone. Welcome to episode 157 of the J Situation Podcast. I'm recording this on April 4th, 2023. How are all you wonderful folks doing? Yeah, man, I hope you're doing well. I'm doing pretty well. It has been pretty outside. Really great for shooting. Really great for doing work outside. It's awesome. Storms are coming, though. That sucks. Yeah, at least down south. I don't know if you guys have been paying attention, but it is crazy. I thought it was going to stay clear, but it's one of those springtime things. It's like April showers bring May flowers or something like that. I heard that's true, and it appears to be. So I wanted to do some testing, and then it's like, no, I'm going to rain. But I was out this weekend doing ranch work because it stopped raining for a bit, and I had a chance to shoot the SCAR. And so this episode does have a particular theme. The SCAR, silencer flow restriction, and back pressure, and you. No, I have prepared a few topics I think you folks will find interesting. We'll hit the PEW Science SCAR project update number 10, long awaited. We'll hit some talk about the PEW Science back pressure metric, Omega, which is going to be good for folks, I think, that haven't heard that before, and even folks that have, because I think we have some updates on that. And finally, I have some administrative updates in the last topic prepared for you folks, per typical, just to keep you up to date with the goings-on of the research cooperative and the PEW Science effort at large. Okay, so this is going to be a long episode. I think I have a feeling. I can feel it in my bones. So I'm going to try to get through these quick ad reads. All right, bear with me while I plow through these. No, it's important. Let's talk about my gracious sponsors. For example, the J Situation Podcast is proudly sponsored by Top Gun Range Houston. And you know what? Speaking of Top Gun Range, we are arranging a PEW Science Range Day thing. Don't get too excited. It's just going to be me hanging out there, and you can come see me and meet me and talk about silencers and shoot their guns. And I don't know exactly what we're going to do, but it's going to be cool. And it's in Houston. So they have a 15-lane indoor shooting range, the largest firearm rental fleet in the state of Texas. And so I'm speaking with those guys. I have the date. I want to say it's in May. So when I know more, I think that's been finalized when I have that in my head, and I think when they have some promotional materials about that, I'll let you guys know. And then if you're in the Houston area, come on by, and maybe we talk about guns and stuff. You know, maybe I shake your hand, we talk about silencers or something. Or maybe you shoot a gun. Or maybe not. It's whatever. Okay? So you can do that. So go check them out, Top Gun Range on Instagram at topgunrange.com. They are a supporter of this podcast, and they really do help. Another supporter of this podcast is High-End Armament Technology. That's right, a dealer of exactly that, high-end arms and accessories. These guys are there to find you really high-end and hard-to-find stuff when you need it. Okay, Robert and his crew have decades of experience, knowledge of the gear, infrared sighting systems, rare machine guns, rare Knights armament stuff, rare HK stuff. They're the place to go. Okay, if there's something you're looking for and you can't find it, I encourage you, go to highendarms.com, at Instagram at highendarms, and they even have a Facebook page, which is also High End Arms. That's right. I hope they help you. If you need them to, tell them Jay sent you. And as always, the J Situation Podcast is proudly sponsored by Silencer Shop. Yeah, that's right. There's some good folks over there at Silencer Shop. You can use their kiosk, do your fingerprints and photos electronically. And in turn, you cut down on errors, you simplify your silencer purchasing process, you get a money-back guarantee. It's pretty great. No transfer fees, no paperwork errors, just you and your silencer with no drama. It truly is silencer ownership simplified. Okay? And if check the show notes on every episode of this podcast, there are coupon codes. You can check out one for the free shipping membership of True Shot Gun Club out of Arizona. There's a code there to save you money. And of course, Magpul, the code PSTEN to get $10 off your order of $100 or more when you're stocking up on mags like a lunatic at magpul.com. It's good for you. And finally, and most importantly of all, from now until forever, this podcast is brought to you by PEW Science, pushing the silencer industry forward one test at a time. And visit pewscience.com for the suppression rating, It's the third year of it being publicly released, and I tell you what, it's the simplest and most accurate hearing-safe rating for your suppressed small arms, 3 years running, based on true human inner ear response of the entire gunshot before combustion takes place until all the combustion is gone. That's right. It's the home of the silencer sound standard. 7 sections, the most in-depth and accurate silencer data and analysis in the universe, probably. Check it out at pewscience.com. And you can support the podcast. You can support PEW Science. You can support all the testing I do for you by joining with a membership at pewscience.com. And there's a donate feature if you're not into recurring things. Just, you can donate. You know, a one-time donation. That helps too. Your contributions are appreciated. And if you don't want to donate monetarily, that's perfectly fine too. You can spread the word. You can give the podcast a good rating on iTunes or Spotify. And you can help normalize the use of suppressed small arms. That would be great. That would help everybody. Okay. So the 3 topics I have prepared for you today, and I am excited about this podcast because, frankly, it's going to be great. It's going to be technical. It's going to be awesome. The first topic is PEW Science SCAR Project Update Number 10, Field Use of the KNS diSCARder. That's right, the KNS Adjustable Gas Regulator for the FN SCAR. I'm going to give you comparisons with the Mototech SCARburator with silencers. Yeah, we'll talk about that. Topic 2, the PEW Science Back Pressure Metric, Omega, a research parameter intended to maximize the utility of externally measured data. That's what that is. It's unintrusive, it's simple, it's accessible. Does it have some pitfalls? Absolutely. Let's talk about some outliers in the dataset in that topic 2. And then topic 3, big things happening. Big things happening right now in PEW Science, in internal PEW Science testing and client testing, tons of silencers, a lot of data. Great analysis, I think, will be enjoyed by all this year. Thank you for your patience during these busy times, as well as your support. The members are really helping us continue, so I cannot do it without you. I don't know how else to emphasize that. I really thank you every week. The membership is driving this effort, and you guys, I am in your debt. I think we all are. So thank you very much for that. So topic 1, let's get this kicked off here. At a time of 7 minutes and 30 seconds. Okay, topic 1, PEW Science SCAR Project Update Number 10. Field use of the KNS diSCARder, which is the KNS Adjustable Gas Regulator for the FN SCAR weapon system. I'm going to talk about that. I'm going to talk about the Mototech SCARburator, my thoughts on the 2 systems. We'll talk about silencer use on the SCAR, and that'll dovetail really well into topic 2, I think, as well. I think this is going to be a SCAR-heavy episode. That's funny. SCAR-heavy. It's funny. 7.62 NATO, God's caliber. You know, it has been a minute since I was able to shoot the SCAR. You know, it takes me a while to, kind of try to hit the ground running on the new year, and just it's been so busy testing and other things. The SCAR is such a unique weapon system. It's a weapon system that has been in public hands for quite a long time and was fielded years ago by military groups, right? And, for those of you new to the system. And why did they field this system? Well, they were looking for a light, reliable workhorse of a gun. And what they wanted this gun to do was handle all types of odd 7.62 NATO ammo, no matter where you were in the world. And they wanted a true utility battle rifle, I would call that. A workhorse that it's at home on your shooting bench, or perhaps in a defensive situation or offensive situation. Plinking folks off horses, as it were, in the hills. Might get a good rug where you are there in the world. No, but you could. And it looks cool, really cool, and that's my opinion. So... I mean, you frankly, you do need a grip pod on the SCAR to make it complete, but we can talk about that later. But you do need one, just let that be known. And technically, the SCAR is very interesting. It's not an AR-15 by any means, no. The bolt carrier is extremely massive, and it is actuated rearward by momentum from a piston. That's right. It's a piston-operated mechanism. The piston receives gas impulse from the firing cycle through a gas port on the barrel. And one of the really neat things about the SCAR, something I really like, is that out of the box, the gas port of the SCAR, the effective gas port, is adjustable. That's right. In fact, it's almost infinitely adjustable. Okay? And how, you may ask? How would something be infinitely adjustable? Well, through the use of different set screws. That's right. The SCAR community calls these gas jets. They are set screws with axial holes drilled through them. Okay, they thread into the interface right above the barrel gas port in the gas block fixture of the weapon. They effectively offer you gas port size change at will with only simple tools. Okay, that's what it is. It's a system offering incredible flexibility. It's quite awesome. If you're, in my opinion, I really enjoy that as someone who likes to mess with stuff. And another technically interesting feature about that part of the gun, on a factory SCAR, there is a gas regulator switch on the SCAR. This is in addition to the port set screws. That's right. And the switch has 2 operational positions and 1 maintenance position. Okay, position 1 at 12 o'clock sends the gas coming from the gas port through the set screw of your choice that you've installed to the piston head. Okay? It also, this switch, this stock SCAR gas switch, also possesses an axial vent out of the front of the switch. That means a hole in the center. Okay? So the switch, its cylinder body, it fills with high pressure gas extremely rapidly. It pressurizes to the extent possible. It allows gas to act on the piston head, all the while bleeding gas out of the front orifice. Okay? At the flow rate possible due to the orifice size and gas pressure. Understand? Might be choked flow. It's a flow problem. Okay, we can talk about that later. We don't need to get too technical with that right now. Now, position 2 with the factory gas regulator does the same thing as position 1. Okay, it does the same thing. It lets the same amount of gas from the gas port into the cylinder of the regulator, but it adds a feature. It does this. Position 2 does the same thing as the 12 o'clock position, but it adds a flavor, and what it does, it opens a free vent orifice to add to the amount of venting going on simultaneously with the piston loading. So in other words, and I'm still talking about the factory gas regulator on the SCAR. When you buy the SCAR, if you feel me. Okay? So what I'm saying is, in other words, that second position, position 2, it gives you more venting. Position 1 has venting. Position 2 has more venting. Okay? Those are the 2 operational positions of the factory SCAR gas regulator. You get venting and you get more venting. That's it. You feel me? Okay. The gas coming in is the same with both positions. Understand? Okay. The third position I mentioned is a maintenance position. And how do you do that? Well, you have to push the little detent in with your fingernail or a bullet tip or whatever, and then you turn the regulator, and you can remove the regulator. That's right. You turn it, and you turn it past the detent there that you pushed in, and then you can pull it out. And that is how you perform maintenance. You change your gas. That's how you can change the gas screws, or if you want to call them gas jets. I use the stock regulator vent setting, like the more vented setting. When I'm using a stock regulator on the SCAR, I put the switch on the vent setting to be my normal setting, and then I would treat the 12 o'clock position, the less vented setting, as an adverse condition setting. Does that make sense? Because you're not venting as much gas, so you have more impulse going to the piston. You can cycle with more energy. Understand? You can do whatever you want. I'm telling you what I do with a factory gas regulator in the SCAR. Okay, so that's and I'm going slowly because I know there's a lot of people going to be listening to this that are new to the SCAR. and wanting to change their SCAR, I want to make sure first you understand what the factory switch does. Okay, it's very important. So that's the stock gas regulator. With that regulator and the potential to use any gas screws to make any gas port size you want, smaller than or equal to the size of the barrel gas port, right? You feel me? You have a ton of adjustability stock with a SCAR, okay? And this is important. Listen to me when I say this. For almost every single person, that's all you need. Okay? Because with this system, you can send as little or as much gas impulse to the piston head. Okay? This would allow you to use a silencer of your choosing, an ammo of your choosing, theoretically, right? Because you can control the orifice size through the set screws. And then you can choose some venting or more venting with a stock switch. Okay, so you have a lot of combinations. You have whatever set screws you have, the number of those you can use times 2, because you have 2 vent settings, right? So that's the possible combinations. So you have a ton of flexibility right off the bat. Okay, it's important for you to understand if you have a SCAR or even if you don't have a SCAR. That's what the SCAR allows you out of the box. Now then, there are other animals. There are other animals you can use besides the stock regulator. Why would you want to do that? Well, sometimes you may have a variety of different ammunition types, and maybe you are a tinkerer who, because you're stubborn, refuses to tune the gun to run with the weakest possible ammo in a certain setting and simplify your life. Like maybe you don't like to be simple and you don't like to take the easy way and you want it to be hard for yourself. So you want this to be complicated. So that's why you would want to tune more. Maybe you're special and you want to use a ton of different ammo and want a different setting for each one, and you are tired of changing gas screws maybe. Maybe you have more than one silencer and you want to experiment. Okay, whatever the case may be, either way, you must have some reason for wanting to vary the operation of the system in a way that's faster than changing the screws for varying restriction. You feel me? Okay, because remember, the screws are a powerful tool. They're a powerful tool. You listening, you in all likelihood don't need a gas regulator other than the stock one. You probably don't need an aftermarket regulator for the SCAR. Just so we're clear, you probably don't need it. But there are options. So now we're going to talk about them. Okay, I think I've done my due diligence explaining to you why you don't need something, because I want to make it very clear for those of you who are new to the podcast, I am not trying to sell you anything. Understand? I am only trying to help you understand it for the benefit of the state of practice and goodwill, because that's the whole point of my company. Okay? 1 second. I do not care what you buy. Now, I mean, you know what, Frank, let me say that a different way. You're going to buy the best stuff, aren't you? You're going to buy what you need, right? Okay. Let's just get that clear, right? Now, if I lead you to that conclusion because you believe me when I say something's good, well, then that's fine. But that's, maybe I did sell you something. I don't know, man. It's your brain. Now, so I'm trying to be nice, but at the same time, it's like, come on. Like I can only say this so many ways. Now, I had, for those of you following the SCAR project, we've done a lot of different stuff with the SCAR, and I had been using that Mototech SCARburator. You guys have heard about that. You've seen it, yeah? So real quick, what's the difference between the Mototech SCARburator and the stock gas regulator for the SCAR? Okay, well, the stock regulator, it has venting the entire time, like I said, and then when you switch it to another position, it adds more venting, doesn't it? It does. The Mototech SCARburator, however, it has the same venting as the stock regulator, but 10 restrictive settings. Different. Okay, so how do you do that? It's like so if you took, and I have them both in my hand right now. If you took a stock regulator and you put it side by side a SCARburator, and I'm going to put some pictures on my website for this in my small arms technical information section later. If you look at them, you'll see. I haven't pin gauged this yet, but I will, all the holes. But you'll see that the Mototech system has roughly the same amount of venting as the vented setting of the stock regulator, but the Mototech system, the SCARburator itself, the entire assembly that you purchase, has 10 restrictive settings that are actuated with a front knob. The knob, when you turn the knob on the front of the SCARburator, the other end of the knob is a helically cut. So, and it's a cylinder, a better way to say that, the end of the cylinder is helically cut. So it gradually occludes the porthole through which gas travels from your gas screw. And it is basically a 10-position gas screw substitute with constant venting. You feel me? Okay, constant venting. So that's the Mototech SCARburator in a nutshell. Does it work? Sure. For what you're doing with it, in the way I explained it, it does exactly what you would think it would do, probably, if you understand that. Okay. Now, enter the KNS diSCARder. Different product. Interesting name. And I thought about why they call it the diSCARder. It's funny. It's a play on words. They capitalize SCAR in the name. It's clever. I thought about why they call it that, the diSCARder, and I haven't. You know what? I had a short conversation with KNS. I have not spoken with them even on the phone. Just it was like a text conversation. I don't know. I haven't spoken with these people really about this. I think it's pretty simple. They probably called it the diSCARder because it is literally a diSCARder. It discards pressure. It's a vent knob, guys. It's a completely different animal than the Mototech SCARburator solution. It's completely different physics. Okay, and I'm going to tell you why. You need to understand this if you can buy this, okay? So, unlike the stock gas regulator, I have all three in front of me. I've been taking pictures of them and playing with them, and it's actually pretty cool. So I have all three in front of me. Unlike the stock gas regulator, the KNS diSCARder, it has one position. Both the Mototech SCARburator and the KNS diSCARder, they have one position in the block. They don't rotate, okay? The only other position you do is when you hit you press the detent and you can turn it to remove it. They stay statically in the block. You do not switch these. You don't switch the SCARburator and the KNS diSCARder like you do the stock regulator. You turn the knobs. Okay, that's a key difference. You need to understand that. Okay, you turn the knobs on the devices instead. So the way the KNS system works, and there are some subtle differences between it and the stock regulator switch and the SCARburator. Okay, and there's more than you think. In the stock switch and the SCARburator, and this is a point where video would be good for the podcast. In the stock regulator and the SCARburator, once you get into the regulator barrel, that is the primary cylinder, once the gas from your gas screw gets into that, okay, once the gas goes from your gas port through your orifice screw, your gas jet, and it goes into the gas block, and then it goes into the hole in the cylinder of these regulators, once the pressure gets in there, it fills a cylindrical volume, okay? The head of the piston resides aft, okay? This is where your piston gets loaded, you feel me? Now, in the KNS diSCARder, they did something a little bit special. There is another cylinder inside the main cylinder. This forms, and you guessed it, PEW Science nerds, an annulus. It forms an annulus. You're like, oh my God, he said annulus. People like that word. It's weird. It's like some people had never heard that term. It's fine. Now you know what an annulus is. It's the space between, like if you put a cylinder inside of another cylinder, and if they weren't tight, the space between the inner cylinder and the outer cylinder wall, that's an annulus. You feel me? Okay, that's what that is. So there's an annulus in the KNS diSCARder, and that annulus is a dead end. In a way, the annular space is the occupied initial volume, but the internal cylinder has a trick. It has an open end. The aft end closest to the piston is open. Okay. The gas comes from the barrel port through the gas screw, through the gas port into the KNS barrel, that cylinder. Then it hits that internal cylinder, pressurizes the annular space, finds its way into the internal cylinder, and there's a way, and let me make sure of this before where's my flashlight? I have my phone, which has a flashlight. 1 second. I'm going to shine a light in here really quick because I want to make sure I hit a point. Yeah. This is important. Okay, so if you let me just take a quick detour. If you take your KNS diSCARder and you hold up in front of you, knob pointed away from you, and you look actually at these down the barrel of this little regulator knob, you'll see the annular space. You'll see a cylinder inside a cylinder. And when you look in there, the annular space, it's a dead end, dude. It's a complete dead end. You're like, oh my God, like where would the gas go? That's so weird. Okay. But then if inside that internal cylinder, that open end, once the gas turns that corner and goes into the center cylinder, it travels forward. That internal cylinder is hollow. And you know what's at the front end of that internal cylinder? Little pinholes, dude. There's little pinholes in there. What are they? They're vent holes. That's how it vents. Now, where they go? Let me turn off this flashlight. Hold on. Should have brought my other flashlight with me. It's on my desk. Hold on. Where do the vent holes go? You're like, oh my God, like it's venting out of a bunch of holes. Like, but you told me that the cylinder was inside. Like, where does it go? Where does it go? Well, the forward part of the diSCARder has a big old hole in it. And if you look through that hole from the side, you can see some of the pinholes in the little internal cylinder. And that big hole in the side of the diSCARder exposing the internal cylinder and those little pinholes can be, you guessed it, gradually occluded by the knob. That's right. And there's 13 positions. Okay? So those 13 positions will dictate how much occlusion you have of a primary vent orifice fed by pinhole vent orifices. Okay? So if you have it on setting 13, the port that exposes the holes in the center cylinder is fully blocked. Okay? And just like the Mototech SCARburator, the KNS solution uses a helical cut on the knob. The difference is that the SCARburator helical cut occludes the ingress gas hole. The KNS helical cut occludes the exhaust gas hole. So setting 13 is fully closed. Okay? And unlike the stock regulator and unlike the Mototech SCARburator, the KNS system does not vent at all when it's fully closed. Okay? So that means when fully closed, you are going to Pound Town, USA on your piston head, dude. You are Pound Town, USA. your piston head is getting pounded. Okay, and with whatever gas screw size, ammo type, and silencer you're using, you feel me? So 13 is what we call max power, pound town. All right, max piston impulse delivery, maximum, max possible. You feel me? Understand what that means? I want to get that across to you so understand that 13 is max power. There's absolutely no venting. Okay, is that different than the 12 o'clock setting on the stock switch? Yes. But it's different in two ways. Okay, and this is subtle. And this is one of the subtleties I was going to talk about. It's different in two ways, and I think they kind of they might offset each other in final mechanism. The stock switch has full-time axial venting no matter what on the 12 o'clock setting, right? It has that center pinhole down the middle of the whole thing. It's going to blow gas onto your muzzle device and silencer or whatever, no matter what, right? That's how SCAR works. Got me? Now, the diSCARder, that internal cylinder, that actually reflects the initial blast pressure that's coming through the gas port before it can go to the piston. So, different geometry, different internal gas dynamics. But what you need to know is that setting 13 is max power, you understand? Okay, so there's some gas dynamics in here that are very complicated. In other words, when the gas comes through the gas port and goes into these two cylinders, whether it be the stock regulator or the KNS system, when it goes into the KNS system, the gas does not behave the same way. It's different than the SCARburator. It's different than the stock regulator. The gas has to take a path that's different. Does that make a difference? It has to. It has to make a difference. Okay? The fluid dynamics dictates it. The does, and shock dynamics does. And this is super high pressure flow. So that does change things. Now, let me get a drink of water 1 second. Okay, now, if you go to setting 0 on the KNS system, and I'm going to select that right now. I have it in front of me. Yep, it's already selected actually because I was looking in the hole. When you have the KNS diSCARder on setting 0 out of 13, that's max vent. That is lowest power. Okay, that means you are exhausting the most amount of gas out of the knob possible. It's a helical cut. And you can actually see all of this from the outside. It's kind of cool. So it should be pretty easy for you to understand. And again, I'm going to post some pictures on my website. As you go to setting 1, setting 2, setting 3, all the way to setting 12, you are progressively closing that vent. When you get to setting 13, which is the final throw position, all the way closed, which is a physical bigger jump than 12. It like the clicks are all the same click. It's like click, 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 all the same click distance. And then once you get from 12 to 13, it's a bigger rotation. Once you get to 13, you're fully closed. And let me tell you, when I tested this unsuppressed on my SCAR, okay, with my gas screw that I currently have installed, with my 13-inch barrel with Lake City M80 ball ammo, that my weapon needed the fully closed gas setting 13 to lock back on an empty mag. I literally just did it on this past Sunday, so it's fresh on my mind. So all this to say is there is, in fact, a difference between setting 12 and 13, in case you were wondering. And I know that sounds weird to say, but like I was really wondering that because when you look physically in your hand, when you put it on setting 12, which I'm going to do right now. Hold up, how do I go all the way? When you look at setting 12, you're like, oh, it's fully closed. But it's totally not. It's totally not fully closed at all. And I can tell you right now that I verified that with my weapon function, so I can tell you it's not fully closed. There is, in fact, a difference. a difference in setting 12 to 13. So there are 13 true settings, and I think that's important to know because resolution, well, we talked about resolution a little bit here, okay? So that's the technical difference, guys. The KNS diSCARder is a vent regulator, and the Mototech SCARburator is a restriction regulator, okay? I think that the KNS diSCARder offers you more flexibility. And this is why. And some of you, actually, I think I said that before. Someone took issue with it. They commented about that. Let me, sir, I thank you for your comment. Let me explain. Okay. I think this is why. You can pick whatever gas screw you want, right? That's the SCAR. I just got done talking about that, right? And how the SCAR works out of the box. Yeah, from FN. You can pick whatever gas screw you want. Okay. Well, that's what the SCARburator does with the knob. All right. The SCAR already lets you do that. You don't need a knob. Understand? So the diSCARder from KNS, it doesn't take anything away from the SCAR. You can still change your gas screws as you always could, but you get 12. You get 12 vent settings with a 13 fully closed. So you get something that the stock regulator doesn't have, which is a fully closed non-vented setting, which is crazy, and you get 12 vent settings, which is 2 more than stock. Oh, I'm sorry, 10 more than stock, and 11 more than the Mototech because it's 1 vent setting. It's constant. You understand? Now, does the KNS system let you adjust the restriction orifice? Well, no, but that's what the gas screws do. Okay, but you can't dynamically adjust the restriction orifice like the SCARburator, but instead you're adjusting venting. Okay, but you get vent settings. And what is the difference between restricting the flow through an orifice and venting out of the volume where the gas needs to enact impulse? What's the difference? Let me say that a different way. What is the difference between changing the flow rate into a fixed volume and doing the same thing but letting gas leave that fixed volume, all the while having a piston inside that must be acted upon by that pressure history? What is the difference between those? What's the difference between restriction and venting in a gas block? What's the difference physically? And we talked about this many moons ago on the podcast. What is the difference between bleed off and restriction? What is the difference between venting and restriction in a gas system, in a gas block? Forget about direct impingement and piston for a second. Understand. What's the difference? Okay. What is the difference? We talked about it when I spoke about, a very long time ago, the superlative arms gas block for the AR. Didn't we? We talked about this. That gas block can be restrictive. It can be a restrictive gas block. It can also be a vented gas block. They call it bleed off. Essentially, the superlative arms gas block for the AR system is a SCARburator and a diSCARder in one gas block for your AR. Okay, just so happens the AR isn't as flexible as the SCAR because you can't change your port size on an AR like you can on a SCAR. So, point SCAR. Now, I have traditionally liked the restricted mode for that system, for the superlative arms system, for the direct impingement gas system. I think there are advantages to the bleed off system from superlative arms. There are advantages to the bleed off function of that gas block. But the problem that I personally had with that system, I was never able to bleed off enough gas to really tune to the degree I wanted to which I wanted, or well, I butchered that sentence. I couldn't tune as much as I wanted to tune because at the time, it was such a long time ago, I think I was using a pretty high back pressure silencers. I was tuning the gun, and for the life of me, I wanted to get the thing to stop cycling, and I could not bleed off enough to have that happen. And I was like, well, gosh, I just can't bleed enough. The bleed hole's not big enough. This is weird. I'm just not gonna use the bleed off setting. It seems super inefficient. The gas screw's poking out way too much. I have a short dwell time, 11.5. It's not gonna fit. It's like, no, I'm just gonna use restricted. I'll call it good. And that's kind of where I left it. Okay, with that. But we talked about this on the podcast. We talked about the physics. The bleed off mode, the bleed off function of a gas block, and again, it doesn't matter if you're talking about piston or DI. The bleed off function of a gas, it allows you to dump excess gas to atmosphere. And what that does, it allows you to keep the initial pressure of the internal pulse, the internal blast load high. Okay, it is highly likely that the pressurization of the gas cylinder volume inside the block occurs rapidly with respect to the vent area. Okay, and I've done some testing on this in bigger systems, so I'm not talking out of my butt. I am talking about with actual fluid dynamic and empirical data experience talking about this. Okay, and if you guys, if there's any folks that want to talk. And correct me, that's okay too. You can send me an email, tech@pewscience.com, or DM me or something to talk about it. But what I'm saying is it's highly likely that, again, I'm going to repeat that, the pressurization of the gas cylinder volume inside the block, it occurs rapidly with respect to the vent area. So what I mean by that is you're reaching peak pressure very quickly on your piston head. And in the case of a direct impingement AR, your gas key, you're getting peak pressure there pretty quickly. But when you vent, you're going to cut the tail off that pressure history. Okay, you're going to cut the tail off of it. So by venting, you can keep that initial pressure higher and reduce the duration of the curve. This is all dependent on time. Okay, this is a dynamic event. We're talking about dynamic event. This is not static. This is not a static event. This is dynamics. Okay, we talked about that. Talked about that many episodes in a row. Just remember, this is all happening over time, so you have to look at the entire event, whether it's outside the system, outside the silencer, or inside your gun. This is all dynamic, okay? So you have a pressure curve, and venting it, it's going to truncate that tail end, but it's going to keep your peak as high as possible, okay? Because remember, guys, what's the area under the curve? The area under the pressure time curve, what is that? Impulse. Okay, so what is that going to do if you vent instead of restrict? Well, most likely, and again, I'm trying to speak in universal terms here. Most likely, this could pay some dividends in weapon operation because you still have your impulsive event to cycle the gun, but you cut it short not to continue to dump energy. Now, I don't know for sure. Again, I don't know for sure, but I believe the kinematics would reveal some favorable and reliable initial velocity components due to early bleed. Okay, I only wish the superlative arm system allowed more bleed. But I digress. Like, we don't have to talk about that. We're talking about the SCAR today. But you understand, I want you guys to remember this. You and I had this talk on the podcast. I spoke to you folks about this it was probably several years ago at this point when we first started to talk about adjustable gas blocks on the AR-15. Or the AR-308 or the Stoner system. Okay, we talk about bleed versus restriction, and in the case of the SCAR, it's so much more flexible than an AR, and we really get to see this impact now. So this has become highly relevant. You understand? 1 second, get some water. It's highly relevant. Okay, so that's why bleeding is neat with the SCAR, I think so far. Okay, I need more time. A lot of irons in the fire, but I'm telling you my experience. I think bleeding or venting, I think it offers you more flexibility. I think it offers you a more consistent kinematic state for piston actuation. And this hypothesis that I'm saying to you verbally so far has been anecdotally repeated to me by another KNS diSCARder user. And I remember, he DM'd me on the gram there, the Instagrams. He told me that, and I quote, had the SCARburator for a while, wasn't that pleased, switched to the diSCARder, and it's a world of difference for me using it on a 16-inch barrel SCAR 17 with a Hyperion K, 1.40 millimeter jet. That's what he said. I said, okay. I told him I had a feeling it would be smoother. I asked him, is it smoother? What do you think? He said, definitely feels like it is. I said, okay. He said less gas for sure. And then he said the SCAR was just meant for venting instead of restriction. And he laughed. And he also said that it behaves in a more linear fashion for him than the SCARburator did. He told me that this is his words, the SCARburator felt kind of all over the place with adjustments. He said he could go 6 clicks and not see a difference. He told me that the KNS diSCARder responded. He said, at least to him, much more like the AR adjustable gas box he's used to. He told me each click was meaningful. I told him, that's interesting. It makes sense given the small volume. It's not a direct impingement weapon. It's a piston. It made sense to me. It made sense. The gist of the whole. I'm not saying every single technical thing is 100% right. I'm saying holistically, his statements track. I buy it, is what I'm telling you, okay? From what I understand of the gas dynamics of the system, from what I understand of operating this and many other gas-operated weapons, I think he's not blowing my skirt up. I tend to agree. He doesn't work for KNS. This is a random dude. Okay. Now, he said some other things. He had very subjective opinions. To him, it, quote-unquote, felt so much better. I told him that is what I hypothesized would happen. I told him thanks for sharing his experience, and he thanked me, told me he's looking forward to this update. Here we are. Thank you, sir, if you're listening. Thank you for your contribution to the research. You're a gentleman and a scholar. How great it was to get a field report at the same time I was doing mine. I thought that was interesting. So now his gun is different than mine. He said he's using the 1.4 millimeter gas screw and a Hyperion K. Okay. Hey, he has a 16-inch barrel. As you know, I'm using a 13-inch barrel. The gas port position on a SCAR is fixed. He has 3 inches more dwell length than me. My gas orifice screw, I pin gauged it. It's 0.059 inches. That's 1.498 millimeters. So it's basically 1.5. He's using a 1.4. So I'm using a 1/10 of a millimeter larger gas port than that guy because my barrel is 3 inches shorter. I got 3 inches less dwell length. That's a reasonable gut check. So that's a reasonable gut check, right? Checks out. So far, math's checking out. I need more gas flow than he does because I have a shorter amount of time on which the gas flow can act on the port before the bullet leaves. Yes, that changes with the silencer, and you understand that, but I'm saying apples to apples. Understand? Okay, cool. Now, this guy, I forgot his name. Sorry, I forgot your name. This guy, him experiencing a better feel with the diSCARder because he's venting makes even more sense when you consider his dwell times longer. Okay, I have a feeling. And again, I would need to use a high-speed camera in addition to other instrumentation to look at some forces. But I have a feeling that more venting is preferable in this situation. I have a feeling. So, what did I do with my system? What did I shoot this past weekend? Okay, well, I left the 1.5 millimeter screw in there. I didn't change my gas screw. What did I do? I took out the Mototech SCARburator. Now, to do that, I had to remove the KDG rail that I like. It's pretty. It's FDE. It's nice. I like it. Had to loosen it because the SCARburator is too long to fit without loosening that rail. It's annoying. And what was an awesome fortuitous surprise, really made me happy. Before I torqued that rail back in place, I untorqued undid the screws. I'm like, oh, this is so stupid. Undid the screws, slid it forward, took out the SCARburator, and before I put the KNS diSCARder in, I was like, huh. I reinstalled the rail with no regulator in place, and at least in the little position, and I kind of hand checked it, and sure enough, the diSCARder fit. And that, my friends, is a huge convenience. Now I can switch my gas screws easily in the field if I wanted. I don't have to remove the rail. It's awesome. I can perform maintenance on the system without removing the rail. Oh my gosh, dude. Oh my gosh. Like, what a better size. It's like, and here's another thing that you might not even think about. And trust me, you probably don't think about this, and it's important. So this is actually one of the most important things about this. You, in all likelihood, will not be able to adjust the KNS diSCARder with your fingers in place. The knob is too hard to turn if you have a KDG rail like me with barely any finger access. I mean, the Mototech SCARburator was hard enough to turn in there. This one's almost impossible because if your fingers are too big to fit in there. So one advantage of the SCARburator from Mototech, the older thing here, you can adjust it by hand, or you can put a screwdriver through the front, through the rail, and through the front of the rail, and turn it. The KNS diSCARder doesn't have a screwdriver slot. You can adjust it from the front with a tool, but the tool you would need, it has two little divots, just like it's identical to the windage and elevation knobs on your aim point red dot. If you have an aim point T1 or T2, you know how you adjust those windage and elevation with a little red aim point tool, little two nubs? That's how you would adjust the KNS diSCARder from the front if you can't touch the knob with your hand. And that would be totally fine, except if the knob was exposed. But I couldn't fit my aim point tool in there, so I couldn't do that. So what did I do to adjust the diSCARder to zone in on the setting I needed for each silencer I was shooting? Well, I literally removed the whole entire diSCARder from the block with my fingers each time. I turned it to the setting I wanted, and I put it back. Is that convenient? Well, I mean, some would say it's not convenient, but it's way more convenient than removing the rail. Okay, so it took a little more time than turning the knob on the SCARburator. Is that an issue? It shouldn't be, dude. You should not be adjusting this that often. Okay, so no, I don't think it's an issue at all. Now, I would, and this is my personal opinion, I would rather have to do that to change the setting and have the venting advantage of the diSCARder. That's my personal opinion. Okay, that's my personal opinion. That's me, Jay. You might have a different opinion. Whatever. Okay, so that's the difference in the two systems, guys. So let me summarize that really quick. The stock gas regulator vents full time, and it vents more if you want it. It's the best. It's bulletproof for most people. Okay, stock gas regulator is the bee's knees because you have the power of all the set screws too. Awesome. The Mototech SCARburator, it vents constantly and it restricts per adjustment. Okay. It's a shortcut for people who don't want to change their screws. That's what the Mototech SCARburator is. It's a shortcut system. The KNS diSCARder, it acts like the stock block to restrict per your chosen gas orifice screw, and it can shut off all venting on setting 13, which is different than the other two solutions, or give you 12 venting settings of various degrees, which is highly flexible. Okay? So that's the overall view, and of course the difference is that the stock regulator is the shortest, followed by the KNS, followed by the Mototech, which is very long, and you will not be able to install or remove the Mototech SCARburator from your weapon if you have a KDG rail on there. Okay, and you can see, look at my scar on my Instagram. You can see what it looks like. Now, and I'm gonna talk about some stuff that some people reached out to me, talked to me. I'm gonna say this on the podcast publicly. I don't mean any ill will to anyone. I'm trying to do this in a professional way. I'm not trying to put anyone on blast. I'm not trying to embarrass anybody. This is important. The owner of Mototech reached out to me and he told me that the KNS system flashes. And the reason I'm saying he told me that is because I want you to know where I got this information. Now, that must mean he has done it. I have not seen that. I didn't see that, but I didn't shoot it at night. So you feel me, understand? So there's that. Now, he also brought up that the water could get in. Now, water can get into the stock regulator or the SCARburator too. So I actually didn't see I don't see the difference except the fact that the vent from the diSCARder is on top of the thing, but like small. I don't think it matters as much. I think water can get in any of your system. That's all the feedback. I don't know. Okay, I'm telling you what I heard. The only negatives of the KNS. Someone said that this guy, the guy from Mototech said that with the KNS system, it can flash and get water in it. I was like, well, I don't know if I buy that as negatives, honestly. Because right now, dude, from where I'm sitting, I love this thing, dude. This is my feedback, right? Okay, it's feedback from me shooting it. It's feedback from the consumer who messaged me that shot it. Feedback from the Mototech guy. I'm not saying the Mototech guy's wrong. I'm just saying I have counterpoints to his argument, which I think is reasonable to say publicly. I think it's important. There's a public discussion. Another thing I'll say, and this is my opinion and my experience right now. I'm not trying to throw shade at anybody. I'm saying another thing I'll say. I think the machining quality of the KNS solution is better. That's my opinion. It could be machining. It could be the finish, the material. I don't know. Something I noticed just in my hand. I'm touching it. I'm feeling it. I use this. Maybe I use this KNS system for a longer time. Maybe it'll look like the Mototech thing does. My Mototech thing is a little rusty and stuff. It's okay. It's not too bad. It still works. I don't know. We'll see how the KNS solution lasts. Being able to remove it from the gun with the rail still installed, it's huge for me personally. That's a huge plus one in my book. But what I want to do, I want to talk about now. I want to move into topic 2, and I want to talk about what I use the KNS diSCARder for as a research tool this past weekend. All right, let's go ahead and do that. Let me make a note here. We'll stop that topic right now, and we'll move into topic 2 at a time of 57 minutes and 28 seconds. Okay, so 50 minutes on that topic. 1 second. Okay, I hope that first topic helped you guys understand the differences between the 3 choices you have as a SCAR owner, whether you are looking at using the stock switch, adjusting your screws, the Mototech SCARburator, using the knob to offer you some kind of pseudo screw adjustment, pseudo orifice restriction, or using a KNS diSCARder, which in my opinion offers the greatest flexibility of the 3 systems. It's not only my opinion, it's physically true. Physically true. It offers you the most. So topic 2, the PEW Science back pressure metric omega, a research parameter intended to maximize the utility of externally measured data. It is unintrusive. It is simple. It is accessible. It does it have some pitfalls? I think it does. I think we've talked about those before. Let's talk about some outliers in the data set, and I think this is going to dovetail great into what we just talked about with the SCAR. Okay? It's topical because like I said in the previous topic, I got to test out some different sensors that use an interesting technology. I believe that most of you have read article 6.40, 640 on the website. It was published years ago in 2021. So I believe most of you have seen it. I reference it in every single review speaking about flow restriction. If there's a hyperlink, I assume that most of you have read it. But what I'm going to do, because I've learned to, due to the feedback I've gotten on social media when I've said some things, people, I can see their eyes glaze over, and that's okay. I'm not insulting you. I'm just saying you clearly aren't familiar, some of you. So I apologize to those of you who are familiar with this, but We got a lowest common denominator sometimes. Okay, we got to make sure to. I know we're raising the bar, but at the same time, this is like really complicated too. So there's a lot of new listeners to the podcast. They might not have been familiar. What I'm gonna do, I'm gonna give you a very brief overview of Article 640 right now. I'm gonna pull up the article. We're gonna step through it quickly. Okay, and we're gonna do it in layman's terms. Okay, per request, and then I'm gonna go into topic 2, and then we're gonna talk about how it applies. We're going to dovetail it with the SCAR system. We're going to talk about CGS Hyperion technology. We're going to tie this up with a bow, okay? Okay. All right. Web browser here. 1 second. All right, let me move this so I make sure my recording doesn't stop. Okay. So what I've done, guys, just like I would do with a review when I go over those with you, I pulled up the article on pewscience.com. It's Article 640. I pulled up the member version. If you just want to read this, the member version and the free version are exactly the same. There's a search box on the website, on the review page, and the podcast page. If you just type in 6.40 in there and hit enter, it'll be the first result. It's super easy to get to this. Okay, and there's like hyperlinks everywhere in the article, so I'm sure you know how to find this. So it's silencer sound standard point 6.40. It's a section 6 of the standard. Article 40, research supplement, the PEW Science Omega back pressure metric. Okay, this is a public article. The title of the article, and I'm not going to read this all word for word, but what I'm reading the important parts. The title of the article is a novel methodology for quantifying relative flow restriction or back pressure of firearm silencers using external measurement. Okay, so in layman's terms, what does that sentence mean? That sentence means a new way to measure back pressure of silencers by using data that's measured from outside the gun. Okay, that's what the sentence means. And then in the article, the introduction basically says silencers make your gun quieter by changing the rate of gas egress from the system. It makes it changes the speed at which the gases exit, and during that time, it lets energy transfer to other mechanisms so that you don't have like super hot, high temperature, high pressure gas touching the atmosphere all of a sudden, because that's really loud. That's what a silencer does, okay? And furthermore, in the opening section, in the second paragraph of that article, I say that if you wanted to do this right, and look, I'm paraphrasing, and if you didn't read this, that's okay, but I want you to know I've said this. I said this years ago. I said if you want to do this right, like perfectly right, it is straightforward. Doesn't mean it's easy, but it's straightforward, meaning that's not a mystery. What you do is you put pressure transducers in the system, and you just measure the pressure history inside the dang barrel. And you do that suppressed and unsuppressed, and you'd figure it out. And you look at the pressure over time, and you could figure out the flow restriction of every silencer. You could do this. You have to use multiple pressure gauges and understand the shock propagation. But okay, we can do that. That's not new physics at all. That's like super simple. Now, in the firearms industry, it might be complicated, but that's not complicated overall because we've done it. I've done this before in other systems. Okay, so anyone can do that. Now, when I use the words anyone can do this, I'm using the collective anyone, meaning that like it's not like you're not a magician. It's just like if you're a test engineer, you could do this. Like if you have understand of dynamics and you could do this. Like I don't mean anyone like you can't go to the high school playground and pick up a little Susie Q and have her do it. Well, I'm not. So you know what I mean. I'm not trying to be pedantic right now, but I'm just saying like I'm not trying to be insulting. I'm not trying to talk down to anybody. I'm not trying to be conceited. But I'm saying this is not rocket science, really. Okay, this is what it is. So up front, I told everybody publicly in writing, I said, look, you could do that and you get the answer and you don't need this. Okay? That's the gist. But what is the second to last sentence of the second paragraph of this article say? It says, the subject of this publication is to present a less intrusive method of flow restriction quantification using existing externally measured data. Then it says, a preliminary research quantity is presented, the PEW Science back pressure metric omega, and I give the units. Okay, so guys, what did I just say? So I just read you the words, and again, people keep asking me for layman's terms. The layman's terms are, here's a way that I think we could be super lazy and use data we already have, examine the metrics, and give us some peg points to figure something out that's like more time intensive to do normally. Okay, let me say that in even a simpler way. This is easier for you, and it might work okay. All right? That's all that says, dude. But you can't say it like that when you write it down because people call you an idiot. So I have to, you know what I mean? Understand? Okay. So I'm getting frustrated because like people, like I get some people, oh, can you explain? Like sometimes when you talk, you're an alien, and I'm like, dude, I know, but like at the same time, listen to the podcast, bro. I can't, you know, like I don't just Google the words if you don't understand them. Like I can't. Come on, man. All right, and not only that, but it's like if this was like a new article that like I just published, I get it, right? But this is like April 22nd of 2021, dude. This is 2 years it's been here. Okay, so if you've been reading it and you didn't understand it, well, you can email me. I can count on one hand how many emails I've had of it in 3 years. So come on now, you feel me? So now I will never shy away from helping someone understand something, and I will never call someone stupid for asking a question. I believe in answering questions to everybody, and I think it's super important to ask questions, and no one is expected to know this stuff. It's super different. But there's a difference between telling me that I need to explain something in layman's terms, which could be totally true, and you know what? I respect your opinion, and thank you for that criticism. There's a difference between saying that to me and being too lazy to read something. Because frankly, I put a lot of effort into this, so if you don't have the time to read it and you're lazy, that's actually not my problem. You feel me? Okay? And now I'm not trying to be mean because I like explaining to you, and that's why I do the podcast. Because sometimes people don't have time to read stuff, and they don't learn as well reading, and they're not visual, and they need to hear something. And they need to hear me talk, and that's cool. That's okay, and that's why I do the podcast. But you understand the folks I'm kind of saying, hey, like, look, if you're super lazy, maybe this isn't the research for you. Okay, maybe don't look at this. Okay, all right. But I think I owe it to the state of practice to talk about it. All right. So I don't want to get too far off track, but I want to give a little bit of an opinion on this because, like, come on, man. You know, I mean, I want to try my best, but at the same time, come on, man. Like, give me some feedback. If you don't understand something, tell me, and we'll talk about it. But don't like pretend you don't understand something. But don't say you don't understand something and you never tried to understand it. That's a BS, dude. Like, if you go in school and you what, you're gonna blame the teacher because they didn't explain something right when you never studied ever? Okay, you know what I mean? That's you know what they call that? A cop out. That's laziness, and that's not something I practice. Or endorse, or I'm okay with. And I will not apologize for that. Okay. With that, I didn't mean to scold you. Let's go into this. So just like, I want to summarize it real quick. We don't need to go deep into this, but bottom line up front, I try to use the existing sound pressure data externally for more utility. We're already looking at how it can damage your ears. I figured, you know what? It's pressure in the free field. It obviously ties to system behavior. How much juice can we get if we squeeze this lemon? You know what I mean? Like, that's what I was trying to do. And I started noticing something, and I go through the history of it. I actually talk about, if you read the article, I talk about in the beginning, I was like, man. And this, you know, I have to say, this actually started with the rugged silencers. Because I did this, I started doing it by myself before I published anything for any of you. I was looking at the rugged silencers, you know, the rugged surge in 2 configurations, the Razor, the Radiant. Because I don't know if some of you guys know this, when the rugged Radiant came out, it was an interesting silencer because in its full configuration, it is the same size as the rugged surge in the surge's short configuration. But you know what? The rugged radiant has a higher flow rate than the short surge. It has less back pressure. You know how I know that? Because the AR-10 I was shooting told me. And the Omega metric told me too. Now, I just skipped 100 steps. But what I'm saying is the amount of gas that dumped out of the silencer, or rather, the speed at which the gas dumped out of the silencer was faster with the radiant than the short surge. And then when I made the radiant shorter, the speed was even faster. When I made the surge longer, the speed was slower. And I was like, oh my God, it's just all it's doing is changing the time. And I started to use time. It was actually one dimension. It was a one-dimensional parameter for the speed at which we reached maximum impulse accumulation 1 meter left of the muzzle. I was like, how fast is the gas getting out? I'm just going to use that as the metric to look at flow restriction. And what was born from that? Revision 1 of the Omega back pressure metric. And this is all in this article. I'm just saying it in layman's terms right now. Okay? So I'm saying that. I was simply saying the faster the gas gets out in time, the lower the flow restriction, the lower the back pressure. Does that make sense? And for a simple system, you might say, oh, that makes sense. Well, so I started looking at that, and I started to calculate it for all the silencers, and then I started to notice it was kind of off, and it wasn't agreeing with the gut checks, it wasn't agreeing with weapon function. I was like, oh, something's wrong. So what I did was like I added a parameter. I was like, you know what? Maybe it's not just the time to peak impulse. Maybe it's the rate. So it's like if you take a slope of a curve, what's slope from like your high school algebra or geometry class or algebra class? It's rise over run. That's the slope, right? Like how far you go on the vertical axis divided by how far you go on the horizontal axis, like rise over run. I'm real simple, layman's terms, right? So like that's the slope of a line. Okay, so how steep it is. So I was thinking, well, the steeper you are, that probably means you have less flow restriction. That means you're really getting that's a measure of how much gas is getting out. So I was like, that's probably like a better way to do it. And so what we did, and you can actually look at how we compared the revision 1 metric to the revision 2 metric by looking at Article 36, because Article 36 was when I changed from revision 1 to revision 2, and that was in the review of the Griffin Armament Explorer. I hate that name. Okay, so I just clicked on review 36, dyslexia went in there, and when you look at that. And you scroll all the way down to figure 8B. God, that wasn't really... you can kind of see how with the back pressure metric Rev 1, you're like, whoa, that's an interesting thing. It shows the Sandman K had more back pressure than like the Explorer. Like that can't be right. The way it and then it's like, that's not right. And then when you see like Rev 2, how the slope, you're like, oh, that looks way more reasonable, and it's like, it does, doesn't it? Yeah, that was a small sample size of like 4 silencers, but at the same time, if you look at figure 9B in that article, I have normalized back pressure metric comparisons with all the rugged silencers, and you can see how the Rev 2 metric compares to the Rev 1 metric, and you see they both kind of work relatively for the rugged silencers due to their simplicity, but there's a little bit more deviation, and so you can. I don't want to spend too much time on that now, but you can look at that. Okay, so and then also just as a treat, if you're really into this, if you want to look at Figure 9A in Article 36, and guys, this is free, or remember, if you want to look at Figure 9A in Figure 36, you can look at the impulse histories of all the rugged silencers. And I actually, that plot that I made, that was actually shown to a major industry party to show them the power of like this type of analysis. And I still to this day don't think they saw that and read it or looked at it. But nonetheless, I am telling you, these silencers follow this logic with flow restriction. 100%, because we've tested it on all kinds of weapons. So there's no argument that the omega metric works. Okay? It works. It wouldn't be published if it didn't. Now, one second. Let me take a drink of water. Now, this metric works. And if I've skipped over some stuff, I'm sorry. I'm trying to go through this article fast. Let me make sure. What was I going to talk about after? Okay, yeah. So that's what it does. And if you want to, and if you don't want to read the math, it's okay. The only reason I wrote down the math is because I wanted to show people like where I got the unit from. It doesn't matter. It doesn't matter, dude. Like, just look at the data. I literally have a picture in there with the same NK in Article 640 in Figure 1. Like, you can visually see what the omega metric is. It's literally derived from the slope of the red line in that figure. Okay? That's all it is. It is super simple, and that's the point. The point is to be simple. I wanted anyone to be able to do it. You feel me? So I wrote it mathematically because you can, because it's just math. And that's because I wanted to show you how I calculated it. So you can calculate it too. And then I said, okay, we can do this. We can calculate it, and PEW Science will do that. And if you want to do it, you can do it too. All you got to do is record raw data the same way. That's okay, because guess what? What is the silencer sound standard? It's literally mil standard 1474 echo in the most strict interpretation, right? PEW Science is the only organization that has publicly released actual mil standard 1474 data. Understand? Like, everyone that says they tested the mil standard, they don't. Because they've never read the mil standard cover to cover and understood it, so they never did it. So all I'm saying is, if you test to the mil standard, if you actually do, you can compute the omega metric too. And nothing's closed source, and it's not proprietary. You feel me? This is not the suppression rating, okay? This is literally math. It's been there since 2021. So when you look at the tables in Article 640, what did we do? Where did we start with the omega metric? We started with a 20-inch barrel 7.62 by 51 weapon. Why? Because that's a gigantic data set we had. And so I started computing them. And what did I do? I plotted them all. So that's what you have right now. On that plot, how do we use the omega metric? Or let me say that a different way. How do we propose? How did I propose this could be used to help people? I said, you know what? If you break it down into 7 zones, it'll probably let you know how silencers that are close to each other behave on weapons. Or let me say that a different way. If you break it down into 7 zones, it'll probably let you know that if silencers are kind of close to each other, they probably do similar stuff to the weapon. How powerful a tool would that be if it worked? It would be really powerful, right? And how cool is that? It's awesome. It's cooler than cool. It's ice cold. And you know why? Because it's literally measurable and computable by anybody. It's open source. You feel me? So, and I'm telling you, and I'm harping on this because it's important. If anyone has told you, and anyone has like poo-pooed this metric because it's some kind of thing and da-da-da, and it's like, I love it. Please criticize it, because I'm going to criticize it today. That's the purpose of this topic, because I'm going to criticize this because there are some holes, some outliers here. But guess what? If you criticize it without adding anything to it or saying why, with any valid criticism, you're a waste of time. Okay, so I used to listen to those people. I no longer do, because they're a waste of time and space. They don't matter. They just want to make noise. So The bottom line for the omega metric is table 3 in Article 640, which is zones 1 through 7. And the title of the third column, or the heading of the third column in that table, says postulated potential qualitative functional influence on semi-automatic or automatic weapon systems. And it ranges from Omega Zone 1 that says normal function all the way to Omega Zone 7 where it says weapon tuning, highly recommended for gas-sensitive host weapons. Okay, I purposely wrote those descriptions. Okay, now, so far, and remember, back pressure is not blowback, okay? Back pressure is the flow restriction that a silencer induces. Blowback is a function of the weapon system that could happen with high back pressure depending on where your system is, okay? Okay. Now, it's all on the website. Figure 2, which is updated every time I release a 308 review and is grown, it ranges from the Sandman K all the way to the Nomad L. Just so happens to be 2 dead air silencers. Didn't pick it that way, just happened, okay? This range of omegas is published in the 2 years since the omega metric has been published. I can count on one hand how many people have given me direct feedback to contradict anything. When we're about to get into the meat of this topic. When I commented about the CGS Hyperion and what I think it does, I got several people telling me that they agreed with it being an outlier in this scenario, and we'll talk about this in a second, but they told me it's an outlier. And you know what my first thought, I didn't say it to them, but you know what my first thought was? Like in my mind? I didn't say it out loud. My first thought was, why did you not say anything before? And I think it's because they don't have enough silencers. But one of the people, and they're supporting PEW Science company, it's not a silencer manufacturer, they told me the only discrepancy they have found in the pewscience.com data set has been the omega zone of the Hyperion. Now that I have highlighted the fact that the Hyperion may be in a different zone, despite its omega metric being what it has been computed as, now that I've highlighted that, they said there's no discrepancies in their experiences. Now, that's an excellent thing for me to hear as the owner of a company. That makes my heart feel full. I take that as a huge positive and a win. But I also see it as a big problem because I didn't know that they had a discrepancy. They didn't tell me before now. And I would ask that if you are listening to this and you understand what I just said, please, if you are noticing outliers in the data, do not be afraid. Please tell me. Okay? The most productive way to do that is send in an email. Okay? That's the most productive thing to do. You can put me on blast publicly. That's probably less productive. Okay? So I think that you can use your best judgment about what to do, okay? Because there's been a couple. There was a public one where someone, said that his Hyperion worked differently than his Nomad, short Nomad, and da-da-da. And you know what? Right now, I'm about to talk about why. All right? So that's enough about this article. I'm going to close it. I urge you to read it. If you don't have to read all the math, just read like the summary, dude. And if you don't want to, that's okay too. I hope this podcast helps. All right. I'm going to minimize that. All right. Let me get some water. I knew this was going to be long. Okay. In fact, should I get dinner? Probably going to, I'm going to cook something. I have enough time. Okay. So I plan to go through that now. You can see, now that we've talked about the article, you can see that the omega metric is an externally measured externally measured and computed quantity, and for most silencers, it lets us get a feel for how fast gas is moving through the system, doesn't it? Intuitively, you would think that. And why? Why can we make that gross blanket statement? It's because their input pressure history is so closely tied to their output pressure history. Those two variables are tied together. But there is a challenge for such a simplification, isn't there? Because things can happen in a silencer prior to the gas exiting. And I'm speaking vaguely, but these things that can happen can create pressure differentials that influence what travels or can travel back down the bore. Okay? Of the gun. The CGS Hyperion technology, and if you're not familiar with that, I urge you to read the reviews on pewscience.com about that. The CGS Hyperion technology, I postulate, is an outlier to the mechanism I just described. Yes, the gas takes a long time to exit the silencer. That is not under debate. That is one of the reasons why the Hyperion is so quiet on many systems. But what the gas does when it enters the silencer is a lot different than in a lot of other silencers. And I understand that you know that. And I understand that a lot of people are, well, duh. Well, I know. But remember what we were doing with the omega metric, okay? We're trying to we're trying to squeeze the lemon. We're trying to squeeze the lemon. You know what I mean? All right. Now, okay, I was thinking about getting political about something. I'm probably not going to do that. Don't want to. Okay, I'll just say this. How am I going to say this? Sometimes people get like super, like, I don't know, maybe because they're bored and they don't have like an important job, or they like to cause trouble because they're bored. Sometimes like people like to talk bad about different people, and they like to talk bad about different companies that make things on the internet, because it makes them like feel better about themselves or something. Like, I don't know why people do that. It's like insecurity probably. If you let your emotions or whatever like stupid drama you feel is happening with these products get in the way of your understanding of like how they work, like you're part of the problem that's been the silencer industry for like 3 decades. So like I'm kind of sick of like I'm sick of reading it. I'm sick of hearing about it. And then frankly, I don't like, it's a waste of my time. So like if these brands aren't your favorite, like I don't care. I'm here to make this better. And if you never shot a Hyperion, or you never will, I don't care at all, dude. Like, believe me. Like, if you never own a silencer, also, I don't care. But you need to understand how these work, because it's not normal, and there's a reasons why it's patented. All right, like people invent stuff that does things that other stuff does not do, and people try to protect that by patenting it. Okay, that's like, can it be protected all the time? Are people still going to rip it off? Absolutely, because people steal. They steal every day. Okay, I'm just telling you. Listen, if you care about this, listen. The Hyperion silencer was designed for a semi-auto sniper rifle. Okay? That's what this silencer was designed for. And it works really well for that. I put a production version of the full-size Hyperion on my SCAR. Okay? With the gas screw I mentioned in the previous topic, okay, with a KNS diSCARder, I had to do some ranch work. I had to cut some wood. I had some quick time to put some rounds through the weapon with a few different silencers. It allowed me to map SCAR function with the diSCARder and do a quick field check of the omega metric with 308, which is a big deal because that's the omega metric I published, okay? Okay. So what did I do? And this is not a complete study. This is a pilot study with the SCAR. I just got the KNS diSCARder. Just bear with me, okay? The silencers I chose for the short field outing, they all shared similarities. Okay, this is important. I installed the tapered thread adapter on the SCAR, which is awesome. So I shot a full-size Hyperion production version. I shot the Hyperion K. It's my R&D model with it has a special end cap on it, whatever. I shot the Helios QD Ti with the CGS tapered direct thread mount. And finally, I shot a Hyperion 1.5, which is a special R&D prototype Hyperion silencer that is 1.5 inches in diameter and shorter than the Hyperion. It's scaled down. It's scaled smaller. It also has a tapered interface. I have two of them. One of them's half 28. Sometimes it's cool to be PEW Science. You're not going to get one of those. Too bad, so sad. Just whatever. It's literally an R&D unit, and it's actually like pertinent here. I'm just telling you what I did, and it'll be in the picture when I post this podcast. You'll see it. Okay. I don't know. Maybe you will have one in the future. I don't know. All I know is like there's not many of them, and I have two. Now, what did I do? I did something all you do. I did something all of you do when you tune a gun for a silencer. I figured out the gas block setting I needed to lock back on an empty mag with my ammo of choice. Okay? I'll spare you every detail, but what I discovered was that the Hyperion needed the same KNS diSCARder setting as the Helios QD. Okay? That's extremely interesting. It's very interesting. You wouldn't necessarily think that would happen if you looked at Figure 2 in Article 640, right? I'm going to pull that back up. When you look at Figure 2, when you look at that big old semi-log scale chart of all the omega metrics, when you look at it, you wouldn't think that. All right? The omega metric calculated for the Hyperion, it's 2.37 there in zone 7. But the omega metric from Helios QD is in, what does it say? 0.52, and that's in zone 6. Well, it's like a different, it's like, what in the world? What in the world? Okay. Different. So the first possibility, I'm going to sneeze. Hold on. Oh, man. Hold on. Oh, God, I had to hold it in. Oh, man, that was bad. Okay. Sorry, I reached for the pause button and then it got me. Sorry. I think, how could the Hyperion need the same setting as the Helios QD? We're talking about direct thread, both silencers. How could it need the same setting? I think there's two possibilities. Okay. Now, and some of you are not going to like these possibilities, but there's two possibilities. Possibility one is that the SCAR would have needed, like no matter what, it would have needed that same setting for any silencer above a certain flow restriction. It could be possible, right? Now, is that likely? I don't know. Probably not. I don't know. I need to run other silencers next time I go out, maybe this weekend. Don't know if I'm going to have time. Not sure yet. That's possibility one. Possibility one is that the SCAR above a certain threshold with that KNS thing, it's like, maybe we hit the top of it with the Helios QD. I don't know. I don't think that's true, but but it is one possibility. Weapon system, right? Every weapon system is different. Possibility two is that the Hyperion doesn't obey the omega metric simplified rule. Okay, that is a possibility. And this is what I wrote on social media. The omega metric hypothesis and the derivation says that if you get gas out slowly, your flow rate is lower. Okay, that's the whole simplified case. That's the correlation we were looking at, the omega correlation. Now, if you get gas out fast, your flow rate's fast. That we think that too. That's another postulation, right? So when you think about it like that, for all intents and purposes, the omega metric should be conservative. Right? It's not like you're gonna it's not like you're gonna have a super low omega metric and like your back pressure is gonna be really high. It couldn't be. But maybe the maybe the omega metric is too conservative for some silencers. Yeah, see. Yeah. It might be that the Hyperion vents very fast in early time internally to the annulus, and this, in conjunction with something that happens in later time, causes a deviation between its omega zone and the gas dynamics on the gun. Maybe the omega metric's too conservative for the Hyperion. Or the Hyperion is an outlier. Call it whatever you want. Understand? Those two sentences mean the same thing. Okay, cool. Now, all that being said, I talked about possibility one, the SCAR not carrying above a certain threshold, and possibility two, this other thing going on. I think all that being said, possibility two is probably more likely. One second. I don't know for sure, but I think it's likely for the reason I just spoke about, my experience on the SCAR, and also anecdotal experiences I've been getting from users on some different weapon systems. Okay, now this is something important. People, I use that word collectively, people, including CGS, report that the Hyperion seems to rob gas. I use that term as exactly what it says. Robbing, stealing gas. I see it as taking gas after uncorking from the muzzle and sending it to a place where it's not able to contribute to increased dwell time or barrel column pressurization. Okay, we saw this with the Hyperion K's omega metric and the short nature of the silencer dumping gas faster, so the omega metric does correlate. But the big Hyperion, it seems to not correlate as closely. It's different. Now, it's not as short as the Hyperion K. The annulus is bigger. It has more baffles. So you would think the big Hyperion has higher back pressure than the Hyperion K. And it does. The Hyperion does have higher back pressure than the Hyperion K. What did you say? The full-size Hyperion does have higher back pressure than the Hyperion K. But it still does what the Hyperion K does in early time. Okay? I mean, look, the silencers are identical up to a point. The gas does the same thing at first. The muzzle jet passes the first hole, and it can enter the annular space. And once it does that, you get continuous jetting down the bore line. Okay? And at some point, they recombine the annular gas and the primary jet. At some point, they recombine. It is this recombination that actually does allow the annulus to effectively act as a reservoir, I think. That's my current hypothesis. You avoid stagnation. Most silencers that use an annulus, to achieve super low back pressure vent that out the front. If you instead recombine, you get a special case. And that is part of the Hyperion technology. It's only part of it. Okay? This is what I was talking about earlier. And to be clear, like, that's what I'm like, guys, I don't care if you don't like this. Like, to not think about it and to disregard it is not special. is irresponsible of you if you care about silencers, because there's no other silencer that does this. So like, you know what I mean? So like, we're talking about something that's like, it's never been done before, as they say. You know what I mean? Right? It's like unique, right? So what if you were able? What if you were able to keep early time flow rate high? Stick with me. What if you were able to keep early time flow rate high and late time flow rate restricted? What if your flow rate curve was so dynamic that you could prevent extreme back pressure when it counted? Like when it counted for the weapon, you could prevent it. And then you could let it happen when it was less important. What if your flow restriction curve was highly nonlinear in early time? Forget about flow through and not having any blowback. I'm not talking about that. Let's just talk about strict weapon system operation for function. You feel me? Okay. What if you could ensure that your carrier speed didn't run away due to excessive pressure waves coming back down your barrel? What if you could do that and be quiet? My hypothesis is that the Hyperion might do that. Okay? Now, it's been a minute, and frankly, like, I don't remember the review number of the Hyperion. I should have done this a long time ago, but look, I've been busy. Okay, and I'm sorry, I'm just now getting to this, guys. Has this, like, made people not like the Hyperion because they thought it had higher back pressure? Maybe, dude. I don't know, but, like, we are where we are. Okay, I'm trying to do my due diligence. All right, with information that I have is available to me. You get it? I have a lot of irons in the fire. So should I have looked at this earlier? Yes. People put this thing on a 300 Blackout MCX, the SIG Rattler, the low visibility assault weapon, the LVAW. Also, they put it on that. People that like shoot people in the face for a living put it on that. And the Hyperion, sometimes it won't let the gun cycle on the suppressed setting with subsonic ammo. It won't let the gun cycle. Okay, now, like with subsonic ammo. Now imagine if what happens. Imagine what happens if what I said just holds true. This is the highly duration-dependent gas trap mechanism I spoke about before. If your event is super short and you send that gas somewhere in early time and no more comes, and you don't have to recombine, there is no more gas. If your event is super short and you send that gas somewhere in early time and no more comes, what happens? The gas is effectively gone to the weapon. It's gone. The barrel won't see enough of a pressure increase over a long enough duration, so there won't be enough impulse through the gas port to cycle. Remember, pressure over time, impulse. Pressure times time, impulse. You robbed pressure. You robbed impulse. You robbed gas. You stole it. The Hyperion stole your lunch money. It's actually a running joke right now in R&D discussions. The Hyperion will steal your lunch money and your girl. That's right. It'll steal your lunch money and your girl. That's what it's doing. It's a unique silencer. It is special. He's biased. No, dude. Believe me. I can buy any silencer I want. I'm telling you, dude. This silencer is not normal. It does not do what other silencers do. I'm telling you, dude. So sometimes the Omega metric won't work as well. So far, it seems to work really well for the incredibly simple silencers. It really does. Seems to work pretty well for OSS, even, due to the way those vent. Seems to work fine for the rugged and dead air silencers. Even though I think actually the Nomad TI might need more evaluation. I think I need to look closer at how I computed that perimeter on the initial slope. Because you know how like some of these silencers have that double slope. I might need to average the two for the perimeter to hold for like to make the simplified metric consistent. Understand? I think the Nomad T. Suffice to say, let me say it in a more simple way. I think the Nomad TI actually might be more similar in back pressure or more similar megametric to the Nomad 30. I don't know. Is the metric perfect? Absolutely not. Is it free? Yes. Guys, we have the data. We have the waveforms, guys. The parameter is literally free to compute. Like, I don't mean like free as in like money, like free as in time. Like, it's there. The data's there. You can compute. It can be useful. Take it for what it is. If you have anecdotal controlled data from a controlled environment to contribute like we have for the Hyperion, now send it to me. Send it to me. Let me look at it. Don't hide. Again, I got DMs. People were like, I knew it. One guy sent me a meme. He's like, vindication. I laughed at the meme. It was funny. But I'm like, guys, if you think you know something, email me, dude. This is public research. This is a public article. Throw stones. And you know what? Same goes for all these silencer companies, dude. I hate mentioning this. And I know people get upset. Some people get upset when I mention this stuff. But I want to be fully transparent with how I feel to you guys. I see what these silencer companies say about me behind my back, because of course it all gets back to me. I see what they say, and that part doesn't bother me. That much. What really bothers me is that if they would just speak with me directly, maybe they would understand this better. It's like middle school or something. There is no place for stubbornness and immaturity in research and science, guys. There's no place for it. You're wasting my time and your own time. And if you don't have an open mind, you're going to fail. Okay? Here at PEW Science, with PEW Science member companies and consumer members, and all of you listening because you took time to listen to this, we're going to win. Okay, we are the ones that are going to win. And winning is all we're going to do. The PEW Science companies are going to win everything. They're going to win the game. And they're going to keep winning for a long time. And you know why? Because because this is objective data and analysis. That's all you need. All you need is keep telling the truth and do it useful as a community. And that's how you win. Okay? So the next outing, I'm going to bring some more silencers. You know what, guys? Let me really quick explain the difference. Oh, I almost forgot. Let me get a drink of water 1 second. Okay. Let me really quick, before I forget, I was going to move on to the next topic, but really quick, before I forget, I'm going to explain to you the difference between a Helios QD and a Hyperion K and Helios DT, okay? I'm going to draw it in front of me. I'm going to draw it on my paper here so I can talk through it with you. Okay, draw this, and then the gas goes in there, and and then this one, and then it's going to go a little closer, and then there's going to be a jet, and it's higher pressure, and it goes into aimless. Yeah. Okay, so why does the Helios QD have higher back pressure than a Hyperion K? Forget about the fact that it's a little longer. Why does the Helios QD have higher back pressure than a Hyperion K? Is it because it's longer? Nope, sure isn't. It's because the Helios QD is a Hyperion with the initial expansion chamber oversized. I spoke about the performance of the Helios QD on the Mark 18 weapon system and how the Hyperion technology in the Helios QD was not able to activate. Some people made fun of me for saying that. That's because they didn't look at the silencers. If you don't have a high enough pressure differential at a certain point inside the geometry of the Hyperion system, you will not get gas into the annulus fast enough to correctly interface with the recombination event, and you will instead only use the primary bore path for suppression primarily. Okay? The distance of muzzle jet orifice origin to the first orifice of the CGS rifle silencers, you could refer to this as a deflector plate in some models. The distance to this, or baffle, the distance to this hole is critical. Too close and not good. Too far, not good. So in the Hyperion and the Hyperion K and the Helios DET, which is a Hyperion K threaded half-28, you are able to take full advantage of Hyperion technology, and your early time flow rate is maintained. In the Helios QD, when the muzzle uncorking event occurs in the first expansion chamber, your pressure drop happens expediently because you have too much gas expansion. Because of your rapid expansion of gas and this rapid pressure drop, the next orifice flow is of a different amplitude, and it will not jet into the annulus. On 308 bolt action, we noted that the Helios QD was quieter than the Hyperion K. I can tell you that if you put it on 5.56 short barrel, the trend will reverse. It has to do with the muzzle jet. It has to do with the muzzle jet diameter and the pressure and the distance to orifice. And I can tell you that you can turn a Helios QD into a Hyperion K, proving this theory with my mount I designed that is a conical cone, redundant, a conical geometry that simply funnels the gas directly into the orifice, or mimics mimics it kind of. Yeah, roughly. I've tested both. They're close. So that happens. That's that story. And now you also understand why there's higher back pressure in Helios QD, because of that rapid expansion of gas, which lowers the pressure in the blast chamber, which, you guessed it, stagnates flow. And what does that do? It increases the propensity for shockwave reflection back down your barrel to your gun. Okay, so that's how that happens. So next outing, what I'm going to do is I'm going to bring some more silencers with me, and I want to keep in mind this is a brand new apparatus, because never before have I had a 308 system with this much adjustability. The KNS diSCARder is the best research tool for me right now for this particular study. I didn't have it before. Yeah, I had a Mototech SCARburator, but it's not as linear. It just doesn't work as well. To keep everything apples to apples on the SCAR, what I'm going to do, I'm going to keep my taper adapter. So it's as if I have a tapered barrel. I'm going to leave that on there. And I'm just going to use a SIG or Q bushing on the taper adapter and put other muzzle devices on that. That way, it would be the same as if you use these silencers on a fixed rifle. You understand? Just like it has a tapered barrel. It doesn't matter if it doesn't match your 13-inch SCAR. It's not about you. I can understand. Okay. So tapered direct thread can connect to the taper. 90 degree direct thread with the bushing will work. And 90 degree the mounts will work, surefire, whatever, with that bushing, understand? Same. So what happens if possibility 1 holds true and I put a Nomad L on this thing and it uses the same setting as the Helios QD? Well, that'd be nuts, right? And then what if the Hydrogen L does the same thing? You know what's going to happen if that happens? I'll be like, well, crap. The SCAR is like not a good gun for this to test with, and I'll be like, okay, well, now we need a different host to like highlight this, right? That sucks. You know what I would have? You know what? If that happens, I don't think it will. But if that happens, you know what I'm gonna have to do? I'm gonna have to put the 16-inch barrel on, and say it louder for the people in the back, because I know what you're about to say. You know why that is? Because because the dwell time would be super long and it would be more gas sensitive. That's right. So that would be the next step. You feel me? We would change barrel to 16-inch. We would get more dwell time, and then we would be more gas sensitive. We would have to understand. And then if it happened again, then we cross that bridge when we get there. But that's even more unlikely. Okay. Because you know what that would mean? That would mean that the SCAR is like not gas sensitive, which we know isn't true. So, right? Because in addition to this, and this is the last thing I'll say about the SCAR today, in addition to this that happens, the normal stuff you know about in an AR, on a SCAR, and I'd be remiss if I didn't say this to you, on a SCAR, you know how you're going to break your SCAR? Yes, you that I'm talking to. You know how your SCAR is going to break? You're going to take a super high back pressure silencer after me talking about this. You're going to take a super high back pressure silencer. You're going to put it on your SCAR. And you're going to adjust that gas. And you're going to shoot the heck out of this gun. And what you're going to miss is, if your early time flow rate isn't high enough, all that gas adjustment in the world is going to stop that shock wave from coming back down your barrel once your bolt's unlocked, slamming into that bolt, accelerating that bolt into the carrier, and cracking your cam path in your carrier. So in everything I just said, not endorsed by me or a fan. Do not void your one trigger in your gun unless you're cool. Topic 3 at a time of 1 hour, 55 minutes, and 49 seconds. Okay, this was long. All right, I'm going to pause this and get dinner started, and I'll be right back. All right, I'm back. I had to get dinner started. So, Mrs. PEW Science and I are going to eat dinner. I was like, looked at the clock. I was like, well, we've been recording for 2 hours. It's ridiculous. Okay, topic 3. I wanted to spend a long time on those topics because there was a lot to say, and I didn't even cover it all. I didn't cover everything I wanted to. Suffice to say, I am so excited for that KNS diSCARder because of the research possibilities with a full-bore 7.62 weapon. Plus, it's one that I love. Now I have a really great adjustment range. How cool is that? It's such a great perimeter. I just think venting is good for piston guns. I think venting might be good for all guns. Is it quiet to vent? And no, it shouldn't be. But you know, with guns like this, you're probably gonna wear hearing protection, dude. Like 13-inch SCAR. Come on, man. Don't be a hero. Topic 3: big things happening in internal PEW Science testing and client testing. Tons of silencers. A lot of data. I think a lot of great analysis is going to be enjoyed by all. And I really wanted to thank you for your patience, because I know sometimes it takes a long time for me to show you stuff. And most of all, thank you to the members, because we've been very busy. And right now, I'm gearing up for some more test programs this early this year. And I'm also gearing up to publish some things that have already been tested. And there are just different things in different hoppers happen in parallel, and that's kind of how I do things here at PEW Science. It's how a lot of businesses do things, and I just want to let you know. I'm kind of trying to give you a window, I can't tell you everything, but I'm trying to tell you what's going on. So what you can see publicly, you can see that some big companies have let folks know that they're testing with me, which is highly unorthodox, but totally fine. It's up to them. Okay, like Air Precision, you saw them. They announced that publicly. Yes, I'm working with Air Precision. Okay, so that's important. So you know some stuff's coming there. There are a lot. There are also things coming that I think folks have waited a long time for, that I will be testing soon. So like that I haven't tested yet, but I will, and I'm excited. So I know you will be. So that's cool. The 14.5 data is really something I'm super hyped for. I predict a resurgence of different silencers folks might not have normally thought of as doing well on 5.56. That could be cool. It could completely change the game with regard to like the data set and like people's opinions and understanding of weapons. Now, I have a quick administrative update. I have a few of them. Here's one that's important, or at least it was communicated to me as important, and I'm going to do a courtesy. I'm going to give a courtesy to a friend right now. An employee from Dead Air told me that they have updated the rated strength of their chemo mount to be okay per their policy to be used with 300 Remington Ultra Magnum. Okay, if you recall, when the chemo came out, it was not rated for that. Okay, He brought that to my attention after one episode. I forgot what episode it was. I mentioned that the type of mount, the deader chemo, is not as robust as threads because the limit state of failure is shear through some tabs on the chemo. Okay. That's why I said that. I stand by my statement. The threading's stronger because it is. I know it is. I mean, this is literally like I can do the calculation and show you that it is stronger. So perhaps they have changed something or done analysis or testing or whatever that they now are rating their chemo for 300 Remington Ultramag when they weren't before. I don't know what is different, whether it's procedural or material, or I don't know. It doesn't matter because it's not my circus and it's not my monkeys. I'm just relaying what I was told to you. Okay, so if you have a question about the strength of that mount in its current iteration, you're going to have to contact the manufacturer, okay? But I'm just doing a solid to a friend who asked me to address it because a lot of people listen to the podcast, and I wanted to make sure you guys had the most recent information available, okay? More administrative things. Regarding the member welcome emails, I've gotten most of them out. I think I need to get a few more. Please be patient if you've not received one. Thank you for your patience. Regarding ads in the member reviews, there should not be any. There should not be any ads in the member reviews when you log in. If you're looking at the member version of the reviews, if you are seeing ads when you view the member content, it may be on the sidebar of the website, which is a global website component. If those, I don't know how to fix that right now. If those ads are bothering you, I'm sorry. You can always use an ad blocker and just take all the revenue away. I don't know what to tell you. I'm sorry. Okay, if it's interfering with the viewing on your browser, you need to use a different browser. Because I don't have any problems with Chrome. But then again, I don't use an iPhone, so I don't know. I don't know if it's like. I know it's not a desktop problem. It's got to be a mobile problem. It might be. I don't know what it is. If you have details about that, let me know. If you're still having problems, okay? Okay, I got some feedback. I wanted to mention it. Regarding questions for me that are technical, please use the pro@pewscience.com email address. That's for pro members. That's what pro members get. That is a direct line to me with priority support. If you are not a pro member and you still want to email me, that's awesome. That's totally fine. Use the tech@pewscience.com address. As always, no worries, dude. Totally cool. Sometimes so the tech@pewscience.com, sometimes I respond faster, sometimes I respond slower. The pro members do get priority and more of my time. That's why it's like $2 more of contribution per month. Okay, it's not that much more money, but I'm trying to give you guys more value. Cool. All right. I think that's all I had for today. I may give you guys an article on harsh signature versus boomy signature versus typical signature on the Mark 18. We'll see. It depends if I test this weekend. I don't know. I'm trying to gauge what I have on my plate. There's a lot going on. I'm trying to really pack a lot of information into you right now. I know this podcast was incredibly long. I hope you found the information useful, particularly if you're a SCAR owner, particularly if you had questions about how gas systems work, regardless of direct impingement versus piston. And I hope the omega metric discussion was useful. Please, if you have questions about it, I implore you, email me. There is no question that is stupid. All I ask is that you try to understand it first. Okay? Is that fair? Deal? Okay, deal. All right. Thanks for tuning in. I hope you learned something. I hope you enjoyed it. I'll talk with you folks again soon. All right, bye.